All right, good morning. My name is Dan Friedman. I'm a data center technical solutions architect. I work for the America's Partner Organization at Cisco. We support partners in the Pacific Northwest. And the purpose of this presentation is to discuss automation and orchestration. This presentation is suitable for both business and technical audience. So let's go ahead and jump in. From an agenda perspective, this is what we're going to cover. First, we're going to discuss common terms that often come up in automation conversations. This is not an exhaustive list of terms, but we will cover the fundamentals. Then we will discuss methods of provisioning. There are a lot of different tools and approaches available. So at a high level, we need to understand the pros and cons of each of those approaches. Then we'll get a little deeper into the tools and skills, and that's where we'll get into a breakdown of how various popular tools and skills fit into the methods of provisioning. Then we'll talk briefly about infrastructure as code, what infrastructure as code means in the context of both public and private cloud, and the tools that are available. And then we'll change gears a little bit and talk about Cisco products and automation. How automation is related to Cisco products and enabled by Cisco products. And then finally, we'll wrap up by pointing you at some resources and training materials that might be helpful based on the tools and skills that we discussed during the presentation. So why are we starting by defining common terms? The reason for that is because in conversation with others, certain terms have a range of different possible definitions or understandings. This means that the definitions sort of change depending on the context of the conversation or the understanding an individual has on a particular topic. So, for example, automation, the term automation ranges from, let's say, the Linux server administrator running a shell script to applying a service profile to a blade server on a Cisco UCS system. And similarly, orchestration ranges from using Ansible to restart multiple hosts to using Cisco's Intersight Cloud Orchestrator, which has a low-code drag-and-drop UI for building workflows that complete tasks across multiple types of infrastructure. So, all of these understandings of automation and orchestration are technically correct, but this variation of definitions can result in conversations around automation feeling a lot like herding cats, like the conversation is getting away from you. What we don't want to do is conflate terms like automation and orchestration, which are often used interchangeably, even though they have distinct definitions. So developing a vocabulary around automation and being able to clearly communicate automation concepts will help bring sanity to your automation conversations, and it will also help you and your team build credibility with customers. The definitions given here are very small, very concise, very succinct, and you'll notice that they focus more on the generic goals behind the terms than any platform-specific context. The definitions of these words also bring proper context to the conversation about automation and orchestration tools, which we'll be talking about later in the presentation. So, it helps understand how each tool works, how each tool compares to other tools, and so on. So to cover the definitions, they're listed here. Provisioning can sometimes be interchangeably used with the word deployment. That'll come up a little later in the presentation, but for provisioning, we're really talking about the setup of physical or virtual infrastructure. For automation, we're talking about the speed of change to a single IT system. For orchestration, we're talking about the coordinated speed of change to multiple IT systems. Imperative means specifying the explicit steps one by one needed to reach a desired end state. And declarative, you don't specify the explicit steps, you just specify the desired end state, and the system determines the explicit steps that are needed on your behalf. When something is done manually, a human executes points and clicks or types in commands at a CLI, versus when something is automated, a script or software program executes commands on behalf of the user. Okay, so these are some common terms that should be helpful in discussing the rest of this presentation. So moving on, we are now going to talk about methods of provisioning and deployment. I mentioned earlier provisioning and deployment. We defined provisioning on the previous slide, but not deployment. I like to think of provisioning in terms of infrastructure and deployment in terms of applications. Provisioning manually via GUI is acceptable for one-off configuration tasks or when the total number of objects that need to be configured in the destination system are relatively small. And that's because pointing and clicking is very time-consuming, especially when you have thousands of objects to configure. Provisioning via CLI and API are ways of more quickly achieving configurations in bulk. Oftentimes, GUI fields and buttons are just a front end for an API anyways, which means that software interprets user input inside the GUI and converts and sends that data to be processed by a programmatic interface on the back end. Now, provisioning via CLI can happen either manually or via automated means. Provisioning manually via CLI involves an operator typing in multiple commands and parameters in a series of ordered steps to achieve a desired end state. This imperative form of configuration is not much faster than provisioning via GUI because you've got to type in many commands and parameters, and that takes time, and you've got to focus on your syntax. If you get that wrong, you've got to enter the command again, and so on. Provisioning via automated CLI involves assembling all of the necessary commands and parameters in advance and putting them into a script or other format that can be executed with very little, if any, input from the user. So this is still an imperative form of configuration, but when it's executed, it's much faster than typing in the sequence of necessary commands and parameters by hand. Often, CLI commands are also just a front end for an API, which again means that software interprets the user input at the CLI and then converts and sends that data to be processed by a programmatic interface on the back end. Now, provisioning via API can happen only via programmatic means, but there are still two types. We mentioned imperative and declarative. So imperative API configuration is like provisioning via automated CLI in that it involves assembling all of the necessary commands and parameters in advance into a program that can be executed with very little, if any, input from the user. Declarative API configuration involves sending an entire desired end state configuration to the API. The API itself receives and interprets the data as the user input, then dynamically determines the steps necessary to achieve that end state and executes them all in the appropriate order. This means that intelligence is built into the destination system, and it does most of the heavy lifting on behalf of the user, which improves deployment time and consistency of results. Now, CI/CD is a means of integrating, approving, and deploying application code onto server infrastructure via automation rather than provisioning the underlying network storage or compute infrastructure itself. So the first three terms, GUI, CLI, and API, to me really relate more to the provisioning of infrastructure and systems, whereas CI/CD really has more to do with deployment of applications. CI/CD is not going to be a focus of this presentation, but rather than provisioning network storage or compute infrastructure itself, it's still worth mentioning. Now, based on the above discussion, the most direct, unabstracted, and therefore expedient mechanism for configuring systems in IT today is clearly via API. As I already mentioned, right, the GUI and the CLI are often just an abstracted front end that where the input gets converted into data that's sent to an API on the back end anyways. So APIs can be implemented in many ways, but the most common today is a REST-based API, which communicates over HTTP or HTTPS protocols. APIs leverage several different potential authentication mechanisms. They can send and receive data. They can rate limit the number of inbound requests in a given period of time, and so on. APIs therefore provide integration or communication between disparate systems that need to exchange information. APIs written in different programming languages can exchange data in common structured formats such as XML, YAML, and JSON. So even though program A on computer 1 is talking to program B on computer 2, and those two programs, and maybe program A is written in Java and program 2 is written in C, those two programs can exchange data using a common format. And those would be, like I mentioned, XML, YAML, and JSON. Okay, so now that we've kind of covered the different methods of provisioning and deployment, and let's go ahead and look at tools and skills that are needed for each one of those methods. So we're starting with GUI, the GUI method, and like I mentioned earlier, this is manual points and clicks by a user. And, each product has its own GUI. So if you think of Amazon, it's got the AWS console. If you think of Microsoft, they have the Azure portal. If you think of Cisco, you've got the Cisco APIC GUI interface. If you think of VMware, you've got vCenter or ESXi, and so on. Every product has its own GUI, and it's often part of the minimum viable product because purchasing customers may not have the skills needed to use CLI or API tools right out of the gate. All right, so moving on to the CLI. When we consider CLI tools, these can be broken down into CLI tools that are used for manual one-off tasks or CLI tools that are used to automate multiple tasks. So for the manual one-off tasks, again, similar to the GUI, each product has a CLI. So Amazon has the Amazon AWS CLI, Microsoft has the Azure CLI, Cisco NXOS or Spine Leaf in an ACI topology all have a CLI. Granted, Spine Leaf is significantly reduced by comparison to NXOS in terms of the commands available, and even VMware has ESX CLI. Or we have Ansible CLI as an alternative, which can perform commands across one or multiple hosts at the same time. For example, to start services, stop services, restart the machines, etc. Now, for the automation of multiple tasks, we have things like shell scripts, which combine single commands that are typically executed manually via CLI, and they're collected into files. And so Bash scripts for Linux are typically held in .sh files, and PowerShell scripts for Windows are typically held in .ps1 files. Or we have Ansible playbooks, which essentially take multiple Ansible CLI commands and combine them together into a script called a playbook, which can then be used to perform commands across one or multiple hosts at the same time. Ansible leverages playbooks which execute multiple tasks in serial or in parallel across one or multiple systems. Each task leverages a specified module, and the module allows specific manipulation or control of a certain type of target system. Now, we also have the option of something like Python with the Nornir library. And we'll talk a little bit more about libraries as we go through the presentation. But this is essentially provides the same capabilities as Ansible playbooks, just not using Ansible. You're using Python now. So this last bullet point sort of takes us into a bit of a conversation about Ansible versus Python. And this conversation should always be about selecting the best tool for the job, right? You typically don't use a screwdriver to pound nails, and you typically don't use a hammer to twist screws. It's always best to consider what is the best tool for the job before you set out to automate something. Okay, so before I get into Ansible versus Python, I want to preface this by saying, Cisco has some level of partnership or cooperation going on with Ansible. For example, we have modules. There are Ansible modules that allow you to configure various aspects of Cisco ACI. There's also a generic REST module that will allow you to speak to basically any device that has a REST-based API on it to achieve various configuration tasks for that particular API. Also, I guess regarding Python has become one of the more well-known programming languages that has been adopted by the network engineering community. It's by no means the only option. I personally have found, I'm not a computer science major when I was in college. I don't know multiple programming languages. I have a network engineering skill set, and I found Python relatively easy to pick up, considering I had essentially zero programming experience when I began. So for that reason, Python might be an attractive option. Neither one of these are Cisco-specific technologies, so the information that I'm giving here is based on my own experience. This isn't a recommendation from Cisco one way or another. It's just my personal opinion. So a bit about Ansible. Ansible is agentless, which means that there is no Ansible agent that needs to run on the destination systems that you wish to manipulate or control. Everything is executed at what's called the control node. Because of that, Ansible requires SSH or WinRM for Windows and Python on the destination system on which it runs, and on the target systems which it controls, because the control node is going to push commands and modules to the target systems via SSH and WinRM, and then execute them on the destination nodes. Again, you've got to have a means of transport, and that's SSH for Linux or WinRM for Windows, and then you also need a mechanism for execution, which is going to be Python, because Ansible is based on Python. Ansible has its own domain-specific language. The abbreviation that you might see for that is DSL, Domain-Specific Language, which is captured in configuration files called playbooks. And those playbooks are written in the YAML format. It's a human-readable format. There's plenty of resources online to help teach you YAML. And if you take an Ansible course, you'll be learning YAML as you go. And at the end of this presentation, I provide some resources for an Ansible course where you can learn YAML skills and format. Now, Ansible playbooks have multiple tasks, and each task, as I mentioned, leverages a module, and each module is uploaded to the target machine and then executed. Ansible modules are written in Python, and that's why Python must exist on the target machines where the module is ultimately executed. Ansible can be configured so that managed hosts check in with the control node periodically and pull playbooks rather than executing playbooks from the control node. So it sort of reverses the flow of traffic and execution. Instead of a push from the control node to the destination machines, the destination machines can actually check in with the control node on a scheduled basis, to keep things, to keep the configuration updated on the destination. Now, when playbooks are executed on a target machine, they are what's called idempotent. This is one of those terminologies that we left out of our definitions earlier. Idempotent means that the execution is only going to change things that need to be changed. Otherwise, no change occurs. So that's a key sort of architectural feature of Ansible that you need to understand. So when you write a playbook, that playbook might say, install Apache Web Server on this Linux node. The thing is, if Apache's already installed, we don't want to install over the top of it, so nothing is going to happen in that case, and that is an example of idempotency. Ansible found its genesis and greatest strength as a configuration management tool. As such, it's very good at loading software, things like using yum or apt. It's good at starting and stopping services, placing .conf files using Jinja 2 templates, adding firewall rules to firewalld or UFW, and so on. Ansible does not have powerful logical constructs like a typical programming language does, right? It doesn't have if, elif, else for decision making. It doesn't have for or while loops. Although it does have minimal looping capability, it doesn't have nested looping capability. And that can be important when you get into more complex scenarios. Now, customers love Ansible because they perceive it to be simpler than Python. So let's talk a little bit about Python. The way I describe Python is it's a lot like a tool belt, and Python libraries or modules are like the tools that you load into your tool belt. Python is an advanced programming language with powerful logical constructs that give it more flexibility in what it can accomplish. So it has all of the if, elif, else, decision-making, for, while loops, nested looping, and more. Python libraries save you time from having to recreate the wheel and range in capability from simple capabilities like date and time manipulation to complex mathematics and video rendering for video games. So the breadth of what you can achieve with Python is a lot wider. That may or may not be important to you, right? Because you may not be trying to render videos in video games with Python, but you can still take the knowledge you have built from your base and leverage those skills towards the video rendering component if and when necessary. Python SDKs, which stands for Software Development Kits, are platform-specific and often developed by the same developers or team that is responsible for developing product functionality. And what this does is it allows you to more quickly get started with the functionality of a specific product because functions within the SDK are tailor-made for that particular product. Now, Python, like I mentioned earlier, has become the most popular programming language in the networking community for automating tasks. So at the end of the day, as I mentioned at the beginning, it's always about picking the right tool for the right job. I personally have chosen to focus my skills on Python rather than Ansible for multiple reasons. Number one, Python runs faster than Ansible, and that's because Ansible is an abstraction of Python. So there's like a translation that needs to happen from the Ansible module so that Python can execute it, and that's why Python runs quicker. Python also scales better than Ansible. Again, because it runs faster, you can address automation against a larger number of machines in the same period of time. So therefore, it scales better. Python is also easier to troubleshoot than Ansible. When you get an error message in Python, it basically tells you what file and what code line blew up. Whereas because Ansible is abstracted, it's a little more difficult. And by default, when you're running a playbook at the CLI, basically your debugging level is not turned on. So you have to enable debugging. There's different levels of debugging, and that debugging can become very verbose and somewhat difficult to read. Python's rather straightforward. So finally, if I need to write an Ansible module to achieve functionality that isn't already available in a published module, then I need to learn how to write and troubleshoot Python anyway. So, for me personally, I've just decided to focus on Python. In addition, there's a few more reasons. From a skills development and maintenance perspective, as an individual engineer, I cannot know everything at an expert level. So I'm going to focus on Python, and I'm going to let other engineers focus on Ansible. This is an important thing that will come up if you've got a business and a team of engineers. You know, try to understand, right, that this concept, right, one person can't know everything, and you're going to have different levels of specific skills on your team. Python skills and fundamentals can be applied to many types of programming based on the libraries that you use. So, for example, you can also use Python for AI and ML use cases. And Python also integrates with several web development frameworks such as Flask and Django, which allows for development of modern, dynamic, database-driven web applications. So that's quite a lot on Ansible and Python. Should give you a good fundamental understanding of what these tools are and how they work and how they differ from each other. Maybe some of the pros and cons depending on how you're looking at it. All right, so now moving on to the API tools. When we consider those, these can be broken down into imperative approach and declarative approach. So for the imperative approach, we've got a couple of different things, right? We've got Postman, which allows you to formulate REST API calls using a GUI. So you provide, whether your call is a GET or a POST, you provide a URL, you may provide authentication information, data that you want to send if it's a POST, and so on. Now, Postman has some limitations with regards to, for example, spreadsheet processing. The example I typically give here is you can tell Postman to execute multiple API calls, one per line in your spreadsheet, and use the data in the spreadsheet inside your API call. So, for example, maybe you wanted to create 1,000 users, but Postman, at least at the time when I was using this tool, might read the first 100 lines or 100 users and create those and then basically crash. And so you would have to reopen Postman, you'd have to edit your spreadsheet, remove the first 100 users that were created, launch the automation again, and then it would proceed with the remaining 900 users. It would process the next 100 users and crash again. So, that limitation kind of slows things down. So alternatively, we also have Python with the requests library, which allows you to formulate REST API calls using exclusively Python code. As such, you get around the limitations, the crashing that I just described with Postman. Or we've got Python SDKs, which abstract away some of the complexity of the REST API and give you ready-made functions that allow you to consume a specific product more easily. So let's see here. Ansible, I'm reading some of my notes here. Ansible, Postman, or Python requests when configuring highly available ASA firewalls versus Python SDK. So, this is what I meant in my note here with regards to Python SDK is I mentioned that these are usually specific to a specific product. So if we're using ASA firewalls as an example, typically these are deployed in high availability fashion. There's 2 of them. So when you're using Ansible to program your ASA, how do you know which firewall you're talking to? Firewall 1 or Firewall 2? Are those running in active-passive mode, or are they running in active-active mode? And does that matter to Ansible? Same for Postman. With the Python SDK for the ASA firewall, I've actually used this. The SDK knows how to establish a connection to the ASA, and it understands the fact that there's actually 2 of them. So you don't have to worry about whether or not you need to send your command to Firewall 1 and Firewall 2, or do I just send it to Firewall 1 and Firewall 1 syncs it to Firewall 2. You don't have to worry about any of that. All that's taken care of for you by the nature of the SDK itself, which, like I was saying, this makes it easier for you to get started with a particular product, because these sort of underlying assumptions that you might have to worry about, you no longer have to worry about when you're using the product-specific SDK. Now, for the declarative approach, a couple examples. We've got Amazon Cloud Formation Templates, which is Amazon specific. You can't use that against Azure or any other platform. You've got Microsoft Azure Resource Manager templates, or ARM templates for short. Those are Microsoft specific. You can't use those against Amazon or any other platform. We also have Terraform, and Terraform uses what's called a provider plugin based architecture. Terraform is one domain specific language or syntax that you need to understand, which means that you can learn once and apply to many different environments based on the plugin, the provider plugin that you load into your instance of Terraform. So one language or syntax that you can apply to Amazon, Microsoft, Google, Cisco, ACI, etc. And so for that reason, Terraform has become a big focus in the industry for basically infrastructure provisioning, in particular in the cloud, right, in the public cloud. Now, when we consider source control, this is where we're talking more of application development, code level development. We need a place to store our code, and that is known as source control. And oftentimes, CI/CD, which we'll talk about in a moment, is tied into or very closely related to the source control platform. So these are different combinations of tools depending on the products that you select to achieve two functions, right? Source control and CI/CD. So you're always going to use Git, and Git is essentially a software that allows you to track changes to your code development process. So you can roll back, you can save your changes, you can distribute those changes to other members of your team if you're using a centralized source control repository. So if you use GitHub for your code repository, then you can use what's called GitHub Actions for CI/CD. If you use GitLab for your code repository, then you can use GitLab CI/CD for the CI/CD portion. If you use AWS Code Commit for your code repository, then you can use AWS Code Pipeline for CI/CD functionality. If you use Azure Repos for code repository, then you can use Azure Pipelines for CI/CD. So, we define CI/CD as a deployment method for applications. What this really has to do with, again, right, is writing new code, committing that to some central repository, reviewing that code, approving that code, scanning that code for vulnerabilities prior to approvals, and once an approval has been achieved, then essentially figuring out how to package that code and deploy that code most often in a container-based or microservices-based architecture onto maybe a Kubernetes cluster or Docker cluster or something like that. So the code repository part has more to do with committing code, reviewing code, scanning code, and approving code. And the CI/CD portion is the automation that kicks in after the approval to help get that code into production. Okay, and that can either be a partially automated process that has additional approvals before things go into production, or it can be completely automated, and that totally depends on the culture of your company, the number of releases you're trying to achieve each day, and the speed at which you want to move through your code deployment process and getting that code into production. All right, that's a good talk about tools and skills. So now we're going to leverage that for a quick conversation about infrastructure as code. And, it's important to recognize that any of the previously listed tools that leverage text files, which contain a representation of either process or device configuration, and therefore can be checked into source control, should be understood to be infrastructure as code. So infrastructure as code really refers to the idea that we can externally represent and then apply both process and configurations to systems that we wish to provision. Now, public cloud platforms were built with an aim for achieving the goals of developers as quickly as possible. Therefore, public cloud has a native tool set, validation included, which is intended to enable infrastructure as code. So, to clarify with an example, and I already gave these, right? Amazon has Amazon Cloud Formation templates, and Microsoft has Azure Resource Manager templates. Those can only be applied to those respective public cloud environments. You can't leverage them against your private cloud infrastructure unless maybe that private cloud infrastructure is AWS Outposts or Azure Stack. So when you submit that template, that is like the declarative mode. You hand that to the Amazon or Azure respective API. The API looks at the desired state in your template, and it executes all of the necessary instructions to achieve that desired state in order of dependency. And before it does any of that, it will actually syntax validate your template to make sure that you have included all the necessary dependencies, that you haven't included any commands that are mistyped or don't exist in the API. So all of that validation is built in, right? Built right into the API when you submit the respective template. Now, private cloud platforms, despite certain modern API-driven systems such as Cisco ACI, private cloud platforms were not purpose-built with native infrastructure as code tools surrounding them. Additionally, private cloud networking is significantly more complex than public cloud networking because the underpinnings of private cloud networking haven't been abstracted away from the user. As a result, there exists no way to send an entire declarative configuration to Cisco ACI and have the API process all of the necessary steps of configuration. Instead, you can use Python SDK known as Cobra, which is specific to the ACI system, to achieve configuration imperatively, which means, basically by sending the API one command at a time to achieve the configuration you want to achieve. So you would send maybe a command to create a tenant, and another command to create a VRF, and another command to create a bridge domain, and so on. So this means that the approach to achieve validation for private cloud networks is correspondingly more complex, and due to the lack of native tools to support it, requires an entirely different approach, right? The validation piece requires a different approach than public cloud, right? The configuration aspect can still be done via API. So in summary, right, infrastructure as code in public cloud must be handled differently than infrastructure as code in private cloud, in particular with respect to the validation of your configuration. There are different tools and skills required. The tools and skills needed for public cloud infrastructure as code are captured in the previous slides in the presentation and were mentioned here on this slide as well. So, all of that is to say that a pretty sizable investment would be needed for a team of engineers to convert a particular stack of technology into reality. So looking, at the slide, I've listed here some potential tools, right? So for source control and CI/CD, I've listed Git along with GitLab for source control and GitLab CI/CD for the CI/CD piece. For network validation, there's a number of different tools that are available. There's Forward Networks, there's Batfish, there's PyATS, which was a library released by Cisco, and then virtual network lab capabilities using something like Cisco Modeling Labs. So, the idea that I'm getting at here, right, if you can kind of follow me, is that you have maybe some code that represents a network configuration, right, in your ACI network and or NXOS network, and you want to commit those configurations to source control because you're now going to manage the configuration of your network devices using using infrastructure as code. So you commit the configurations as a text file, aka code, to your source control, and then perhaps you leverage some CI/CD mechanism to spin up a virtual lab for your network inside of Cisco modeling labs. Once those logical devices come online, you would further use CI/CD automation to potentially place those configurations on the virtual devices that just came up in your lab. And then you could potentially leverage PyATS or these other network validation solutions to validate the soundness of the changes that you've just made to your network configuration in the lab. And then after that validation takes place and is approved, then you could potentially further leverage CI/CD automation to move those configurations into your production network. So again, right, the validation piece is leveraging external third-party products, right, and is not just built into, for example, the Cisco APIC API. You're not just sending it, a desired end state configuration. Okay, so the goal would be to provide for private cloud IAC. The goal would be to provide a comprehensive, full stack, working solution for handling the validation. Right. Obviously, in our case, with Cisco networks being the priority. Such a team would need to learn and integrate all of these disparate components of that stack in such an attempt. They might succeed and they might fail. If they succeed, then they may have figured out something that few, if any, people in the market have figured out yet, and that could be offered to all private cloud customers. Absent such a full stack solution, private cloud infrastructure as code would be relegated to one-off processes and configurations achieved by a combination of people, process, and technology components such as maybe Python and or Ansible. Okay, so that gives you kind of an idea that Python and Ansible are tools that can actually do quite a lot, but they are not full stack solutions, and a lot of times they're used to write scripts that achieve little chunks of automation on different systems without the bigger view or bigger picture capabilities. Okay, so now we're going to switch gears a little bit and talk about Cisco products and automation. We already defined automation in the beginning of this presentation as the speed of change to a single IT system. And in the context of Cisco products, I've tweaked that definition a little bit here. When we get away from single system automation or multiple system orchestration, more generally, automation can be understood as taking something complex and making it simple. So I want to talk briefly about one Cisco product because it consolidates a lot of automation capabilities under one umbrella, and that product is Cisco Intersight. Intersight is a modular SaaS-based cloud management platform. And there's other deployment options as well, but the SaaS-based is the most comprehensive in terms of available features and the easiest for customers to get up and running because there's nothing to deploy, configure, or secure. That's all done for you by Cisco. Now, Intersight is based on a microservices architecture, which means that the product is broken up into several components. In this presentation, I'm only going to touch on the components of Intersight that are related to automation. There are additional components as well, but we're going to save that for another presentation. In fact, I've already put together a fairly comprehensive presentation on Intersight. Now, the first component of Intersight worth mentioning is IIS, which stands for Intersight Infrastructure Services. And this portion of the product really found its genesis as an updated management system for on-prem Cisco compute infrastructure. It allows management of HyperFlex and UCS series hardware and consolidates management functionalities from UCS Manager and UCS Central. It is the Cisco compute infrastructure to which all of the features like connected TAC and automated RMA, hardware compatibility lists, firmware recommendations, advisories, field notices, recommendations, and forecasting are all applied. Okay. In other words, those are features that become available when you're consuming the SaaS-based version of Intrasite. So, as an example, in Cisco UCS Manager, we have pools and policies and profiles. Pools are a single point of tracking and allocation. Policies are a single point of configuration and consistency. Profiles are a single point of server personality. And when you combine these things, these simplify the coordination, deployment, management, and troubleshooting of server infrastructure. So, back in the day when a server would go down, you would have an application tied to a specific MAC address on the underlying hardware. So, let me revise that. Maybe the server didn't go down. Maybe the NIC failed, right? And the application's tied to the MAC address on that NIC. That's a real problem, right? Because we all know each NIC has a unique MAC address, so you can't just replace the NIC and still have the same MAC. And your application's tied to that MAC, now you've got a problem. But with UCS, there is no problem. You just assign the server profile to a new piece of hardware. And this wasn't possible, right, before Cisco brought service profiles to the industry. So that can be viewed as a form of automation built into Cisco products at the most fundamental level. At the inception of the product architecture, how can we help customers automate as much as possible? These are things that are always given consideration. And that's not just unique to Intrasite. So with Intrasite Infrastructure Services, we can now extend these same concepts beyond UCS Manager service profiles for Blade servers. Now we have things like server profiles for UCSX, domain profiles, which help us configure networking, HX cluster profiles, which help us configure HyperFlex, K8s cluster profiles, which help us configure Kubernetes clusters, and so on. All right, the next subcomponent is that I'll mention is IKS. It stands for Intrasite Kubernetes Service. Obviously, I'm not going in order on the slide there. This component allows for the automated deployment and management of Kubernetes clusters either on-premises or in the cloud. On-prem, you can do bare metal or virtual. Obviously, in the public cloud, that would be virtual infrastructure. IWO, or Intrasite Workload Optimizer, that's the last one in the bullets there. This component collects data from the virtual compute layer of your on-prem or public cloud infrastructure and then provides you visibility, insights, and actions that you can perform to basically optimize your environment. So in order of priority, Intrasite Workload Optimizer is focused on making sure that your workloads are optimized for, one, performance, right? Because we want to deliver a great end user application experience by ensuring that workloads are not under provisioned. The second priority is compliance, and this is about ensuring proper placement and distribution of workload across your cloud service providers, regions, and hosts, while in adherence to your defined policies about how things should be placed across those resources. And then three, the third priority is cost, and this is about cost efficiency by ensuring that workloads are not over-provisioned and that hosts are therefore not underutilized. So the Intrasite Workload Optimizer works based on the concept of targets. So target systems like vCenter, for example, or storage arrays and so on. The more targets that you add to IWO, the better visibility it has to the infrastructure that it's available to be consumed, and therefore the better insights and actions it can recommend or execute on your behalf. Okay, so there's definitely a component of IWO where you can allow the system to take over and fully automate dynamic changes to your infrastructure, meaning it can upsize your VM to include more RAM, or it can relocate it to another host, or all of that, right? So lots of automation built into IWO. And in fact, the cost savings that you can achieve by kind of building cost efficiency, especially where public cloud is concerned, will oftentimes pay for the entire license for IWO. The next subcomponent is ICO, which stands for Intersite Cloud Orchestrator. And there's that term, orchestration, right? This component provides orchestration capabilities by running workflow automations that are built in a low-code UI by leveraging drag and drop tasks from a built-in task library, or optionally, you can create your own library items. So those workflows can be partially or fully rolled back if problems are encountered. And the product resembles functionality that was previously delivered by UCS Director, but it's actually a separate product. There is an integration between the two, which would allow Intersite Cloud Orchestrator to execute basically a UCS Director workflow, but you can't import workflows directly from UCS Director into Intersite Cloud Orchestrator. The last Intersite component that I'll mention is IST, which stands for Intersite Service for HashiCorp Terraform. And this component provides a tight integration with Terraform Cloud, which is a service that's meant for enterprise Terraform customers. Terraform Cloud allows multi-user access, role-based access control, a remote execution environment, and simple backup and restore capabilities, among other capabilities that are usually of interest to enterprise customers. Terraform, as mentioned previously, uses a provider plugin model, which allows you to target the provisioning of infrastructure across different systems and environments, including on-premises and public cloud. So again, this is used to largely automate the provisioning of infrastructure, whether that's storage infrastructure, compute infrastructure, network infrastructure in the public cloud, and any other targets that are supported by the provider plugins. Now, breaking away from Intersite, I now want to try and start wrapping up this presentation and this piece by mentioning every modern product, whether that's Cisco or third party, has an API, an application programming interface. And that's because the entire industry is trending towards programmability, automation, and orchestration. So I've provided examples. I'm not going to read through them, but I've provided examples of products across these different categories that have APIs. If you walk into a Panera Bread restaurant and use a kiosk to order your meal rather than talking to a human, if the restaurant industry is trending towards automation, then you better believe that the IT industry is trending towards automation too. There's no escaping it. This is the way of the future. There's too much data. There's too much scale. There's too much for human capacity to be able to handle on their own. And so automation, orchestration, programmability, these are all, the way of the future. The fact that every product now has an API means that each of these disparate systems have the potential to talk to and share information with each other. So think business intelligence and decision making. It means that centralized management platforms like Intersite can talk to each one of those disparate systems and as part of a workflow to provision and configure the entire technology stack from the ground up. Obviously, provided that you have an appropriate management network or connectivity to the APIs to achieve that. It means that applications can then be deployed on top of the infrastructure via automation. Multiple release cycles per day, scale up, scale down, etc. These are all examples of automation where applications are concerned. And it really means that any conceivable possibility of access to data and how to use that data within the constraints of what each system can provide, that's what's possible. Basically, anything is possible. So, what it really means is if our customers don't start getting on top of this skill set now, then maybe not today, maybe not tomorrow, but eventually they will not be able to compete in the modern marketplace which they're a part of. If they're a fintech company, they won't be able to compete with their competitors. If they're a medical provider, they won't be able to compete with their competitors. They will be eclipsed by organizations that have made the necessary investments to figure out these skills and figure out how to use them effectively. And as a result, their businesses are only going to be able to move at the human pace, right? And not at a pace which programmability, automation, and orchestration enables. All right, so to wrap up this, I promised some resources and training. So again, these are not all Cisco specific. Some of these are based on courses that I've personally taken. These are not necessarily endorsed by Cisco, but I have found them to be valuable personally. So starting with programmability, you've got DevNet certifications. There's associate, specialist, professional, and the expert level certification is going to be released in June of this year, 2022. So you can get certified in any one of those levels, and if you click on that link, it'll take you to a site where you can get more information for each level. I personally have a DevNet Associate certification. I'm thinking of pursuing the professional maybe later on this year. And what I can say is that the blueprint for the exam was spot on. If you take the time to learn and research each aspect of the blueprint, you shouldn't have any trouble passing the associate. And I assume that that's similar for the other exams as well. With regards to Ansible, I took a course written by a guy named James Spurren. He offers his course. It's called Dive into Ansible on Udemy platform, which is a learning platform, udemy.com. He's a great guy, answers questions. I found a small error, submitted it to him. He pulled it in to his repository and basically fixed it. I also see him, I'm connected to him on LinkedIn. He's a really intelligent guy. For Python, Kirk Byers. Kirk was formerly a CCIE networking expert. He then endeavored into the Python arena and started creating classes for other network engineers to learn Python. So if you click this link, it'll take you to his webpage. You can sign up for a free 8-week introduction to Python. He also has some paid courses. The thing that's most interesting, at least from my perspective about his course, is that it was purpose-built using examples that network engineers can relate to. How can I use Python to telnet into a switch and run commands? How can I run show commands and pull that data back and do things with that information? So I felt that was pretty interesting, and it's a good, it's not focused on Cisco. He uses Juniper and Arista in some of his examples, but networking is networking. So, and Python is Python. So he teaches the fundamentals in this class, and he has additional paid-for classes that you can pursue if that's of interest. With Terraform, I took the HashiCorp Certified Terraform Associate class from A Cloud Guru. I found this to be a pretty streamlined class, good knowledge. There's certainly other classes available on the platform. Similarly, for Kubernetes, there's a Certified Kubernetes Administrator course. When I took it, I didn't know anything about Kubernetes, and I felt like this was a great class for me to get started. Finally, with regards to Intersite, I've provided a link to Cisco Black Belt training. When you click that link, you're then going to want to click on Data Center and then click on Intersite in order to basically get to the necessary materials. There's also Partner, VT, and Voice of the Engineer recordings. If you click on that link there, you'll have access to both such recordings. If you click on Data Center, and then you can expand either the Partner VT and or the Voice of the Engineer sections and search for Intersite. You can find both PDF decks and video presentations there. And then finally, there's additional partner training opportunities that are coming up through our learning providers. These are typically sent out via email to your teams. So stay tuned for new courses that are going to be released between now and early March. All right, so hopefully that was a valuable introduction to automation and orchestration. Here's one last slide that shows the different DevNet certification levels. I guess one last closing note is the engineering track is about 75% engineering and about 25% software on the exam. And the software track is about 75% software and about 25% engineering on the exam. So, I personally found already having a base knowledge of Python was useful to me in the DevNet and pursuing the DevNet Associate certification. And then obviously, having a background in network systems or compute systems, because those systems are discussed from an API perspective inside of this certification track. All right, so that's the last slide. I want to thank you for listening, and if you have any further questions, feel free to reach out to me. My name's Dan Friedman, and I'm a Data Center TSA. Thank you.